In this video, we'll continue examining horizontal parabolas, just now we're going to be focusing on how to graph our horizontal parabolas. We need to make sure we get it in the standard form, x equals a times the quantity y minus k squared plus h. If it's not in that standard form already, we're going to have to complete the square to get it in that form. And once we do that, we can identify a, h, and k to assist us with finding the coordinate of the vertex, the coordinate of the focus, the equation of the directrix, and the length of the lattice so we can graph. In this first example, x equals 1/4 times the quantity y minus 3 squared plus 4. It is in standard form already, so a is 1/4. It's a horizontal parabola with a positive a value, which means it's going to be opening to the right. K is attached to your y, so k is 3. H is 4. So the coordinate of the vertex is HK, so that is 4, 3. So I go to my graph, go over 4, go up 3, and there is the coordinate of the vertex. I'm going to label it with a V so we know what it is. Next, I go for my focus and my directrix. Both of them deal with 1 over 4a. The focus is going to be 1 over 4a units to the right. The directrix is going to be 1 over 4a units to the left. So I need to find out what is the value of 1 over 4a. So 1 over 4a, a is 1/4, so 1 over 4 times 1/4. And that's going to give me 1 over 1, which is 1. So 1 over 4a is 1. So if I want the equation of my focus, I'm going to do h plus 1 over 4a, so h plus 1, 4 plus 1, comma k, which is 3. 4 plus 1 is 5, so it's 5, 3. So my focus is located at 5, 3. I'll put an F there for focus. The directrix is x equals h, which is 4, minus 1 over 4a, so 4 minus 1, which gives me x equals 3 as the equation of the directrix. To graph the directrix, remember we use a dashed line, and this is going to be a vertical line because it's x equals. I can change the color to make it match the focus so we can see the relationship between those. And now to graph the parabola, I need to know the length of the lattice for it. To find the length of the lattice, you do the absolute value of 1 over a. So I have the absolute value of 1 over 1/4. So the 4 comes up to the top. So absolute value of 4 over 1, which is 4. So the absolute value of 4 is 4. So the length of the lattice is 4 units. What this means is you start at the focus and you need to cut the lattice in half, which means you would go up 2 units and you would go down 2 units because that gives you 4 units total. And that represents the location of points of the parabola. So start at your vertex. You're going to come up, curve through these points. I'm going to come down and I'm going to curve through the point I found using the length of the lattice. And there is my horizontal parabola represented by the equation x equals 1/4 times the quantity y minus 3 squared plus 4. Now, I used all the formulas here. And the next example is I'm just going to use the idea and the definition that the distance from the vertex to the focus is 1 over 4a, and the vertex to the directrix is 1 over 4a. Because once I get this value of 1, since I know it's opening to the right, I can just count one spot to the right, plot my focus, and count one spot to the left, and sketch my directrix, and then get the values from the graph. So we're going to try that technique in the next example. Here we have x equals negative 1/8 times the quantity y plus 2 squared plus 3. When I take a look at it, I can see it is in standard form already. Here, a is negative 1/8. That tells me since it's a horizontal parabola, it's going to be opening to the left. Whatever's attached to my y, I have as my k value. So here k is -2, h is +3. So the coordinate of the vertex is hk, so 3, -2. I'm going to plot that first, 3, -2. Here is where my vertex is for the horizontal parabola. It's going to be opening to the left. So I'll label this with a V for vertex. Again, I always go for the focus and directrix, one after the other. I need to know 1 over 4a for this. So 1 over 4a is 1 over 4 times -1/8, which gives me 1 over -1/2. Flip the 2 to the top, 2 over -1, it's -2. The negative tells me I have to go to the left, and that should make sense. Since I told you A is negative and it's opening to the left, that means your focus is to the left of the vertex, and it's to the left of the vertex 2 units. So I'm just going to count from my vertex. 1, 2 units to the left, and there is my focus. Label it with an F. That would be the coordinate 1, -2. If I want to find my directrix, I just count 1, 2 units to the right. And so I'm going to put my dashed line 2 units to the right. Again, I'm going to change the color so it can match our focus because they have the same relationship with distance from the vertex. And this would be the equation x equals 5. So I didn't even bother to use these formulas. I just knew 1 over 4a is the distance from the vertex to focus and vertex to directrix. And I can count on my graph in order to get these points. If you want to use the formulas, you can. It would be h, which is 3, plus 1 over 4a. So plus and negative is subtraction. So 3 minus 2 is 1, and your k is -2. I can do x equals your h, which is 3. You have minus 1 over 4a, so minus a -2 means plus 2. 3 plus 2 is 5. So I can use either the formulas or the concept of the distance from the vertex to focus as being 1 over 4a and the distance from the vertex to directrix, 1 over 4a in the opposite direction, to just find the values without the formulas. Now I'm going to have to do the length of the lattice. The absolute value of 1 over a, so the absolute value of 1 over -1/8. The 8 flips to the top, so absolute value of 8 over -1, which this is -8. So the absolute value of -8 is +8. So the length of the lattice is 8 units. From the focus, I'm going to cut this in half. I'm going to go down 1, 2, 3, 4 units. This represents a point on the parabola. I'm going to go up 1, 2, 3, and here I'm going to have to go off my graph, and there's 4 units. There's another point on the parabola. And then connect with your curve. Start at your vertex, come down and go through the point, come up and go through the point. And we see it's opening to the left, just like we said in the beginning for it. And so there is our graph of this horizontal parabola. Now in number 3, it is the most complicated example that we have for it. This one we can see it is not in standard form already, so we have to get it in standard form. The way I'm going to do that is I'm going to complete the square. So I'm going to isolate the quadratic in the linear term first by moving the 7/2 to the other side. So I have x minus 7/2. I know I'm going to have to complete the square, so I'm going to insert my placeholder already. Equals, you cannot complete the square with a coefficient that is not 1 with your quadratic term. So I have to factor out that -1/8. You do that, you're going to get y squared, and you would get a plus 4y, because negative 1/8 times 4 is negative 1/2. I'm going to insert my placeholder. And now I can complete the square. Take half of your linear term, so half of 4, and square it. So 2 squared gives me 4. So in this placeholder, I put a 4. However, remember, to know what goes in here, you have to keep the equation balanced. You're not really adding 4 on the right side because you're distributing this negative 1/8 in here. What you're really adding to that right side is a negative 1/2. So I have to put negative 1/2 here. Now you simplify. Negative 7/2 plus negative 1/2 is negative 8/2, which gives me negative 4. So I have x minus 4 equals negative 1/8 times the quantity, and I squared a positive 2. So I have y plus 2 inside the parentheses squared. Solve for x. X equals negative 1/8 times the quantity, y plus 2 squared, and you would add 4. And so there is my standard form by completing the square for this. Again, let's identify our h, k values, and our a value for this. It is a negative horizontal parabola because I can see here that a is negative 1/8. That tells me it's going to open to the left. K is a negative 2, and h is a positive 4. That tells me my vertex is located at the coordinate hk, which is 4, negative 2. So 1, 2, 3, 4, down 2. There is my vertex, label it with a V. I still need to find my 1 over 4a value. That's going to allow me to find the focus in the directrix. So 1 over 4a, 1 over 4 times negative 1/8. And that's going to give me 1 over negative 1/2, which is negative 2. So that means I go 2 units, since it's opening to the left, my focus is 2 units to the left of the vertex. There's my focus. And if I want my directrix, I'm going to go 2 units to the right. 1, 2. And there we go. And we can change the color to make it match so we can see the distance between it. Now I can actually use the graph to tell me the points. This is the coordinate 2, negative 2. This is the equation x equals 6. If you want to use the formulas, you could. H plus 1 over 4a, so h plus and negative 2, so 4 minus 2, comma negative 2, 2, negative 2. H minus 1 over 4a, so minus and negative means plus, 4 plus 2 is 6. And now I find the length of the lattice to help me with graphing. So absolute value of 1 over a, I have the absolute value of 1 over negative 1/8. So the 8 comes to the top, so I have the absolute value of 8 over negative 1. So this is negative 8, so the absolute value of negative 8 is positive 8. So the length of the lattice is 8 units. What does that mean? That means I go down 4 units from my focus, 1, 2, 3, 4, plot a point on my parabola, and go up 1, 2, 3, now I'm going to go off the grid 4, plot a point on the parabola. Start your vertex, come down and curve through the point, come up from the vertex and curve through the point, and there is our graph of the horizontal parabola. So in this video, we looked at how to graph from our standard form, and in this last example, we repeated the concept of completing the square to get in standard form. My advice, again, is to make sure you learn what 1 over 4a represents, because once you get that value, you can probably count on the graph and not worry about the formula on finding the focus and the directrix.